Hello everyone. What on this question? Acceleration of an object is given by four t. Velocity of the object when time is 1 second. It is found that its velocity when t is 1 is 5 meters per second. And our aim is to find velocity when time is 3 seconds. Acceleration is 4t. A for acceleration, t for time. Given information is that when time is 1 second, velocity is 5 meters per second. When time is 3 seconds, what is v? Let's see how many of you can answer this question without my help. You've got 1 minute's time to solve this thing. The first information is everybody knows these equations from 9th and 10th. V equals to u plus at. But we will not use these equations in this situation. These are called Newton's equations and we'll learn these equations, don't you worry. But as of now, since everybody has knowledge of these equations, you have seen these equations S equals to ut plus half at square and all. These are used when acceleration is constant. This acceleration is non-uniform. Non-uniform means when time is 1 second, acceleration is 4 into 1, that is 4. When time is 2 seconds, it will be 4 into 2, 8. When time is 3, it will be 12, and so on. So this acceleration is continuously changing. This equation is used when acceleration is constant, and therefore if you need to find velocity, then when you write a as 4t, this will be called this will be called instantaneous acceleration. Instantaneous acceleration. Acceleration at time t. Now, what is instantaneous acceleration? Instantaneous acceleration is dv upon dt. We have seen this part. This tells us that dv upon dt, dv upon dt is what? 4t. The moment you write dv upon dt as 4t, now question says find out v. Now listen what I'm saying. Find out v means you need to remove d. Removing d is nothing but integration. How do you integrate this thing? For integration, you will multiply this dt over here in this form. dv is 4t dt. Then we will use the integration sign. dv equals to 4t dt. After this, you can use two things. First is use of limits. Limits means when time is 1 second, which is a lower limit, velocity is what? 5. You will write 5 meters per second. When time is 3 seconds, we need to find v. Let's call it v3. 3 for velocity when time is 3 seconds. After this, I expect from you that you can integrate the whole thing. So give it a try. Let's see if you can produce an answer now. Is there anyone who used the same approach before I explain this? If you use the same approach, then write down yes in the comment box. Now, what is integration of dv? V. Integration of dx is what? X. Integration of dv is what? V. What is integration of t dt? Integration of t dt is power plus 1 upon power plus 1. Integration of x dx is x 1 plus 1 upon 1 plus 1. Simple power formula in integration. Then, after integration, limits are shown over here. And how do you put limits? Replace this v with upper limit, which is v3. Replace this v with lower limit, which is 5. This is 4 upon 2. 1 plus 1, 2. 4 upon 2. Keep 2 out. This is what? T square. Upper limit is what? 3. 3 square minus. Lower limit is what? 1. 1 square. This is what? T square. Replace t with the upper limit and then replace t with what? Lower limit. This is giving you v3 5 plus 5 plus 9 minus 1 8 into 2 16. That is 21 meters per second. If you understand this process, then write down yes in the comment box. This last part is what? The whole thing inside is 4 upon 2 and t to the power 1 plus 1. This is 2t square. And we have taken this 2 out. How do we use limits? Replace this t with the upper limit minus. Replace this t with the lower limit. Solve this. 9 minus 1, 8 into 2, 16. And then you have moved 5 from the left side to the right side, giving us 5 plus 16, which is 21 meters per second. Now, when a question like this is asked, you can use limits Or you can also use constant of integration. Now let's answer the same question with the help of constant of integration. Write down the first method was with the help of limits. The first method, with this method, write down with the help of limits. Now write down second method with the help of constant of integration. With this, mention that with the help of limits. And then write down with the help of constant of integration. When you go for constant of integration, everything is same up to this step. dv equals to 4 ddt. You will write like this. Now you don't have to show any limits. What is integration of dv? V. What is integration of 4t? 4 t square divided by 2. Same. Plus c. This c you know is called what? Constant of integration. Now what this equation tells us, it tells us that you can find v if you have been given value of time. We know that when time is what? V is what? 5. We had no idea of what this constant of integration is. So what we did, we used the information given in the question. Question is telling us that when time is 1 second, when t is 1, velocity is 5. We have been given this information. And integration tells us that if you know time, then v can be calculated using this equation. Which means v is 5. This is 2. T is 1 plus c. We get the value of c as 5 minus 2, which is what? 3. So this constant of integration which was not known, we found it with the help of this given information. That means now v is 2t square plus what? C. And this c is what? 3. So velocity at any time is 2t square plus 3. If I ask you, find out velocity when time is 3 seconds. Velocity when time is 3 seconds. You will simply replace this t with 3 square plus this constant of integration. This is the formula for v now. T is 3 seconds, you put it here. This is what? 9 to 18 plus 3, 21 meters per second. What is the advantage of this second approach? When you use constant of integration, you always get a formula like this. If I ask you what is velocity when time is 12 seconds, you will simply replace t with 12. If I ask you what is velocity when time is 30 seconds, you will simply replace t with 30. You don't have to integrate the whole thing. Whereas, if somebody is using the approach of limits, then you have to put your limits again and again as they ask in the question. If I ask you velocity when time is 3 seconds, you will be using upper limit as 3. If I ask you velocity at 8 seconds, your upper limit will become what? 8, and then you again and again have to perform using the limits in that function, which is kind of wastage of time, and therefore many a times you will find that this is a good approach, although they both are what? Same things. If you understand this second approach, then write down yours in the comment box. Acceleration is 3t square. 3d square when t is 0, velocity is 5. And you need to find velocity when time is 4 seconds. Put on this question. The acceleration is 3d square when time is 0. Velocity is 5. That is, initial velocity is 5. And question says find out velocity when time is 4 seconds. First method and second method, use both methods and produce the answer. Do it fast. Everybody must use both methods, first and second. Look at the first method, using limits. In exams, you can use any method, first or second, doesn't matter. Acceleration, which is dv by dt, is given as 3d square cross multiply, it becomes 3t square dt. Use integration sign, show the limits 0, 5, 4, and we need v at 4 seconds. When time is 0 seconds, velocity is 5. When time is 4, we need v4. Integration of dv is v. Integration of t square is power plus 1 divided by power plus 1. This is coming v equals to t cube. 3 and 3 gone. Use square brackets. I hope you can see it. And then the limits 0, 4, 5, v4. How do we use limits? Replace v with upper limit v4. Replace v with lower limit 5. Replace t with upper limit 4 cube. Replace t with lower limit 0 cube. Upper minus lower, upper minus lower. This is v4 equals to 5 plus 16, 4, 64. Your v4 is coming 69 meters per second. That's the answer, and many of you got the same answer. Now, those of you who have got 69 with both approaches, if you have got 69 with the help of limits and with the help of constant of integration, then write down yes in the comment box. This is with the help of limits. If you have got the same answer with the help of constant of integration, then write down yes in the comment box. And those of you who could not solve it, put down this. Now, the help of constant of integration. Using constant of integration. And we'll do it fast. From this, you get this integration, which is v equals to t cube. At same time, v equals to t cube, simply add what? C. I hope you understand this. Same thing, just don't use the limits. Don't use the limits. Integrate dv, you'll get v. Integrate t, you get t cube. Don't use limits. Add c. Now, question says when time is 0, v is 5. So you are putting these values in this equation, which immediately gives you what? Constant of integration as 5. That's your c. Once you found c, your v is now t cube plus 5. We need velocity when time is 4 seconds. This is 4 cube plus 5 is coming 69. This is your second method using constant of integration. Note on this. Now write down Newton's equations. Newton's equations. Basically, we are interested in those equations. V equals to u plus at, S equals to ut plus half at square. These things. These are called Newton's equations of motion. But Newton's equations of motion are used only if you fulfill two criteria. First criteria is, write down the statement. Newton's equations of motion are used. Newton's equations of motion are used only if motion is one dimensional only if motion is one dimensional. You know what one dimensional is? Object is moving along a straight line. And acceleration is uniform. And acceleration is uniform. Both magnitude and direction wise. Both magnitude and direction wise. These are the two things which you need to know. Object should not move like this. It should move straight. And your acceleration must be uniform. When I say uniform, it doesn't mean that you have acceleration 5, then you have acceleration 5. We have changed direction. No. Throughout your acceleration should remain what? Same. Magnitude and direction both should be same. You can highlight this part, the part where I mentioned that acceleration is uniform, and after that I told you that both magnitude wise and direction wise, you can highlight that part. Now, when you use Newton's equations, we use few things, and these are what? U, V, S, A, T. Everybody has seen these things, but let's define them again. U is initial velocity. Write down this. U is initial velocity. That is velocity when time is 0. That is velocity when time is 0. V is velocity at time t. V is velocity at time t. S is displacement. S is displacement covered in time t. S is displacement covered in time t. And A is constant acceleration. A is constant acceleration. And t, you know, is what? Time. So, what is V? Velocity at time t. What is U? U is velocity initially, that is when time is 0. That means U is in fact velocity V when time is 0 seconds. You can understand it like this. Just for your understanding, you can write it like this also. U is nothing but velocity when time is 0. V, what does V mean? V is velocity when time is t seconds. So that's how you should understand this. initial velocity. That means velocity when time is 0. V, velocity at time t. This. Now, look here. A. Question says A is a constant number, uniform. This is A. But we know that A is always dv by dt. What is A? Acceleration. But acceleration is what? dv by dt. That is coming A. If this is A, then let's integrate this thing. How do you integrate this thing? dv is A times dt. Cross multiply. Use integration sign. What is integration of dv? V. What is A? A constant number. Constant number, you can always take it out. You can always take constant number out like this. You're left with dt. What is integration of dt? T. Just like integration of dv is v, integration of dt is t plus constant of integration c. Constant of integration c. What is this equation? This equation tells you that if you have time t, then you can find v using this equation. But we have been told that at t equals to 0, we have been told that v has a name. And what is that name? U. At t equals to 0, v will be called what? U. If you say that at t equals to 0, v is going to be called u, this v is u when time is what? 0. A multiplied by time, but time is what? 0 plus c. This gives us c as what? U. We have found constant of integration u. Put this constant of integration in this equation and you get v equals to at plus c. What is c? U. Done. We have developed the first equation, which is v equals to u plus at with the help of calculus. This approach of differentiation integration, it's mathematically called calculus. With the help of differentiation and integration, we obtain first equation. If you understand this derivation, then write down yes in the comment box. If everybody is writing yes, but you find that you still have some doubt, then you don't have to write yes. You can simply say no and mention your confusion, and I will help you out. Just note down this thing and I'll explain it once again. Look here. We know that acceleration is A. For Newton's equations, A must be a constant number. But whatever A is always dv upon dt, rate of change of velocity with respect to time. Cross multiply dt like this. Now, when you write something in this form as a dt, you're basically doing this. Suppose somebody told us that acceleration is 8. What is 8? A constant number. We'll be writing 8. If you write 8, then 8 is a constant and you can take it out, which means you are left with dt. And if you remember integration, then the very first lecture of integration, I told you integration of dx is what? X. Integration of dy, y. Integration of dt, t. This is the very basic part of integration. So integration of dt becomes what? T, and this 8 is over here. But I took 8 just to explain the concept. What is 8? What is 8 in this? A. So this is your AT plus C. After integration, one must use constant of integration. How do you find constant of integration? They will always provide information like this. The information is that initially velocity is u. When I write u means, suppose somebody told us that initial velocity is 5. What we are writing is 5. At t equals to 0, v is u. What is u? U is a number. Somebody told us that initially object was moving with 5 meters per second. Maybe in some other example it was moving with 7 meters per second. Then we'll write 7 here. In some other example it was moving with 23 meters per second initially. We'll write 23. So since we have no idea, we are using a symbol for that, and that is what is u. So when t is 0, question says v is u, replace t, replace v, and you got your c as u. Once you got c as u, put it back in this equation, which gives you v equals to at plus u. That is v equals to u plus at. I hope you understand it now. Now let's see development of second equation. We have got V, which is coming U plus 8T. This format is something like this. V 5 8T. 5 is what? U. Just for example, 8 is what? A. The things which keep on changing are time and V. You change T, V will change. Your acceleration, it will remain same 8. Your initial velocity is 5. For this example, for a different example, you can always take different values. The argument is that V and T, these are the things which are going to change. Now, what is V? V has a name. V is called, let me see how many of you know what is the technical name for V. What is V called? Write down in the comment box. For you, hint is what was A, which I wrote just a few minutes back. No. V has a technical name. What is V? V is, you all are writing final velocity. That is correct. Final velocity means velocity when time is t. But velocity when time is t is called what? Instantaneous velocity. What is V? V is final velocity, which is correct. Final means when time is what? T. At time t, velocity has a name. Instantaneous. What is instantaneous velocity? What is instantaneous velocity? Instantaneous velocity is dx upon dt. Instantaneous velocity is what? Dx upon dt. Now look carefully. When object is traveling along x-axis, you will be using dx by dt. When object is traveling along y-axis, you will be using dy upon dt. When object is traveling along z-axis, you will be using dz by dt. We have no idea whether object is moving along the x-axis, y-axis or z or some other direction. The only thing we know is object is moving straight, and therefore we simply write ds by dt. If you are moving along the x-axis, your s becomes x. For y, for z, accordingly you can change this s. So, instantaneous velocity, which is dx by dt, in a general situation will be called what? ds by dt. That gives us ds by dt as u plus at. Now, cross multiply this dt over here. This becomes u dt plus a into t multiplied by dt. Cross multiply dt, cross multiply dt, you're multiplying dt with this and this. Integrate this whole part. Look, this is plus. If this is plus, you can always integrate something like this in this form. Now, when you integrate something like this, what is the integration of ds? S. What is u? U is a constant number, just like 5. If it's a constant number, take it out. You're left with dt. What is A? A is a constant number. Take it out. You are left with what? You're left with what? T dt. T dt. Then S U. What is the integration of dt? T plus A. What is the integration of T dt? T 1 plus 1 divided by 1 plus 1. That's how you integrate T dt. What is the power of T? 1. And then after integration we use constant of integration what? C. It's a different constant of integration. You cannot use the same value of C which we have taken in the previous example. So when you integrated this, you got this. This is, everybody can see, we have almost reached the final stage. This is ut plus half at square plus c. We have reached almost the final stage. Ut 1 plus 1 2 half at square plus c. Now what was S called? S was what? Displacement in time t. That means what? Suppose object started from this position. Now look at this figure. Time is 0. At this point, object is moving with you initially. Question says at time t it is found over here. At time t it is found over here and is moving with velocity v. You started from A and you have reached this position B. You started from A, you reached this position. So I hope you can see that for us AB is nothing but displacement. What was S called? S was displacement at time t. Now, if I ask you what is displacement when time is 0, you will say that when time is 0, object is at A, you started from A, you are itself at A when time is 0. That means we can say that at t equals to 0, displacement is 0. Listen again. What do you mean by S? Displacement at time t. But if I say that time t is 0, you are at the initial position itself, and your displacement is what? 0, and therefore we will use this argument at t equals to 0, displacement is what? 0. This is the starting position. Object starts moving from this position and it is moving like this. This separation is called displacement. starting from this black marker position. This is your displacement. Well, if I ask you what was displacement, what was displacement when time is 0? You will say that this blue marker was at this position and therefore displacement is 0. This equation gives us what? Displacement as a function of time. But at t0 displacement is 0. Put this information in this. S is 0, t is 0, this t is 0, 0 multiplied by a is what? 0 plus c. Displacement is 0, t is 0, t is 0, c. You can see that constant of integration itself is coming what? 0. Constant of integration is coming 0, and if it is coming 0, then what is s? S is this u t plus half at square plus c, which is 0. That's the second equation, Newton's second equation. That's how you develop it. The whole process is very easy. Just to explain the way constant of integration should be used, I have to explain this figure. If you understand this derivation, then write down yours in the comment box. If you have any doubts, mention your doubts. To slow down everything, look at this constant of integration, this part again. Well, I hope everybody is comfortable up to this stage. This is the integration coming from this, and I'll assume that everybody is comfortable up to this stage. Now look at this. Suppose, take an example like this. This is point A, starting position. When time is 1 second, object, you found that an object is over here, 3 meters. When time is 2 seconds, somebody told you that object is at 6 meters and so on. So if somebody gives you this type of information, then when time is 1 second, and this is the starting point. Starting position. So, what is displacement in 1 second? You will say 3 meters. You started from this is 3 meter. What is displacement in 2 seconds? You will say 6 meter. So, if I ask you what is displacement in 1 second, you are saying 3 meters. When I ask you what is displacement when time is 2 seconds, you will say 6 meters. When I ask you what is displacement when time is 0, you will say that object is at the starting point itself and therefore displacement is 0. This is the meaning of this path. Now we have been given information that S is displacement covered by the object in time t. So if your S is displacement in time t, then at the starting point, time is 0. So what is your displacement? 0. This gives us 0, 0, 0 plus c, which basically lets us know the value of constant of integration is coming as 0. That's the only meaning of constant of integration in this particular situation. I hope you understand this now. Now let's see the next equation. We can develop next equation with the help of first and second, or we can use this equation directly also. We'll see both methods. Look over here. Third equation, first method. Write down like this. Third equation, first method. We have obtained V equals to U plus AT. Well, everybody knows we are interested in this equation, V square U square plus 2AS. When I say third equation, this is the equation we are interested in. I have written this equation because everybody has seen this thing in 9th and 10th. So we are trying to develop this. We have developed this V equals to U plus AT. Now, this is what V square. This is what V. So let's do one thing. Let's square both sides. If you know what to develop, you can always use the correct path. The moment you square like this, or you open a square, a square plus b square plus 2ab. Well, I guess everybody is comfortable with this. A square plus b square plus 2ab. Then, this is v square equals to u square plus, now look carefully. What is this? 2a. Let's do one thing. Let's take 2a common. We have written u square, and from these two, let's take 2a common. Once you take 2a common, first use this 2a common, and you are left with what? Ut. Taking something common means you are dividing that by 2a. I hope you know this thing. When you take something common, you're basically dividing that thing. Ultimately, 2a gone. This is a square t square. From this, directly you can remove this 2a part. What is this? This is u square plus 2a. Look at the bracket. Look at the things inside the bracket. I'm rearranging the things. This is ut plus, what is this? An square cancelled, half t square, which is half a t square. Answer. V square is u square plus 2a. What is inside the bracket? S. Development for the third equation. If you understand this first method, then write down yes in the comment box. We'll take 2 minutes extra for the second method. That won't take more than 2 minutes. Just note down this thing fast. So this is the first method for the third equation. Now, let's use the calculus part. And this approach is good. And you will learn integration only with the help of this. Look here. We know that dv by dt is a second method for the third equation. Pay attention. dv by dt equals to a. But everybody knows that in the third equation, in this third equation, there is no term of t present. T is not present. And if somebody tries to integrate this, t will definitely come. We don't want t. And therefore, look at this part. Multiply v on both sides. Acceleration we have been given is called dv by dt. We have multiplied v on both sides. And then what we did, pay attention to this. What is v called? This right side v, we called it ds by dt. That is the meaning of v, instantaneous velocity. What is v? ds by dt. The moment you convert v in ds by dt, this is dt, this is dt, dt and dt are cancelled, dt and dt are cancelled, and you get v dv, v dv, a ds. We have eliminated the term of time using this approach. Now integrate this. What is this? V dv, which is like x dx, which is what? V square by 2. Again, what is integration of x dx? Integration of x dx is this. Remember this, x dx. We have replaced x with v dv. It will be what? V square by 2. What is a? A constant. Keep it out. Integrate what? ds. What is the integration of dx? X. So what is integration of ds? Integration of ds is s. Let's use a second line for this whole thing. So after this is v square divided by 2 equals to a. What is integration of ds? S plus what? Constant of integration c. Then how do you find constant of integration? We know that when time is 0, velocity has a name. When time is 0, we know that v is called what? U. And when time is 0, we also know that displacement is 0 from that figure itself. T0, v has a name and s is called what? 0. Look at this. V has a name, U. S is what? 0 plus C. Look again carefully. When time is 0, V is U and S is 0. Or you are saying what? Directly you are saying what? When V is replaced with U. When can you replace V with U? When you are at the starting position. At starting position, what is displacement? 0. I hope you can see that C is coming U square by 2. U square by 2. You got value of C. Put this C in this equation. So when you put C in this equation, it becomes V square by 2 AS plus C U square divided by 2. Value of C. Multiply with 2. Multiply with 2 and you get your answer. Multiply with 2. 2 gone, 2as, 2 gone. V square is equal to U square plus 2as with the help of calculus, that is with the help of differentiation and integration. If you understand the second method, then write down yes in the comment box and then you can leave. Thank you very much.